For this last question in the review, we're told that the probability of A is equal to 0.5 and the probability of A union B is equal to 0.8. For what value of the probability of B would the events be mutually exclusive? Now, if the events are mutually exclusive, that means the probability of A union B is equal to the probability of A plus the probability of B, and because they're mutually exclusive, there's no intersection. So now this becomes a very straightforward algebra problem. We have 0.8 is equal to 0.5 plus the probability of B, and we conclude that the probability of B must therefore be equal to 0.3. So that's the first part, if A and B are mutually exclusive events. Part B is a bit more interesting. The probability of A union B would be equal to the probability of A, let me draw a line like this, probability of A plus the probability of B minus the probability of A intersect B. Now, without some other extra information, I'm stuck. There's no way to simplify this unless I have some extra information. Now, of course, in the problem there is some extra information. A and B are independent events. If they were not independent, I could not do this next step, that the right-hand side is the probability of A plus the probability of B minus the probability of A times the probability of B. Now I can solve for the probability of B. So I have 0.8 is equal to 0.5 plus the probability of B minus 0.5 times the probability of B. Bring the 0.5 over to the left-hand side. We get 0.3 is equal to, over here I have probability of B minus a half times the probability of B. That reduces to a half times the probability of B. And then multiplying both sides by 2, we find the probability of B must be equal to 0.6. So if the two events are mutually exclusive, then the probability of B must be equal to 0.3. With these conditions up here, if the events are independent, then the probability of B must instead be equal to 0.6.